Welcome back. We joined us in Chapter 5, Section 2 now, where we're looking at some probability rules. And at the end of the section, we'll be able to give a probability model for a chance process with equally likely outcomes and use it to find probability. We can use basic probability rules, including the complement rule and the addition rule for mutually exclusive events. Use a two-way table or a Venn diagram to model a chance process. And of course, the general addition rule to calculate probabilities is kind of what we're looking at. Okay, so in section 5.1, we use simulation to imitate chance behavior. Fortunately, we don't always have to rely on simulations to determine the probability of a particular outcome. A probability model is a description of some chance process that consists of two parts, a list of all possible outcomes and the probability of each outcome. Now, the list of all possible outcomes is called the sample space. A sample space can be very simple, or in some cases, very complex. Here's one that we have if we roll two dice. Here it is. We got 36 outcomes. This is everything that could possibly happen when you roll two dice. All right, so we see that we have 36 outcomes, and since the dice are fair, each outcome is equally likely. So each outcome has a 1 out of 36 chance of happening. Now, an event is any collection of outcomes from some chance process. So we might say, let A be getting a sum of 5 when two fair dice are rolled. Well, there's 4 ways that could happen. You could get a 1-4, a 2-3, a 3-2, or 4-1. So we would say there is a 4 out of 36 chance, or a, 4 out of 36, or 1 out of 9 chance of that happening. All right. So finding probabilities of equally likely outcomes. If all outcomes in the sample space are equally likely, the probability that event A occurs can be found. Basically, it's the number of favorable outcomes in event A divided by the total number of outcomes, and we kind of found that as well. So rules that a valid probability model must obey. We're going to be looking at this again, like we talked about, that the probability is that the number of outcomes in event A divided by the total number. The probability of that event is between 0 and 1. All possible outcomes together must have probabilities that add up to 1. And the probability that an event does not occur is 1 minus the probability that the event does recur. We call that the complement. And you can kind of see that right here with this is kind of saying the probability of the complement of A is 1 minus the probability of A. Okay, so if A is the event that occurs, then the complement is the probability that A does not occur. All right, now let's say that we roll 2 fair dice. What's the probability of the sum is 6? Well, once again, we look at the possibilities. There's 5 outcomes that could happen out of 36. There's your probability. What's the probability that the sum is either 5 or 6? Well, we could figure out that the probability of getting a 5, now again, we didn't list those out here, but getting a 5 is 4 out of 36, because you could have a 1-4, a 4-1, a 3-2, and a 2-3. So we can add those together, 436 plus 536, get 936, or 1/4, or 0.25. And the reason that we can add those together is because these are what we call mutually exclusive. They are disjoint. They cannot happen at the same time. Okay, can't get a sum of 5 at the same time get a sum of 6. You got to get one or the other. So the addition rule holds true here, where if they're mutually exclusive, in other words, can't happen at the same time, the simple way to find the probability that one or the other occurs is to add those two probabilities together. Okay, now that only works if they're mutually exclusive. Okay, so in symbolic form, we can kind of summarize these. We can say that probability of A is between 0 and 1. We can say that the probability of that sample space should add to 1, should equal 1. And if we have equally likely outcomes, take the number of outcomes in event A and divide by the total number in the sample space. And again, there's the complementary rules. Those are just some symbolic ways of writing those. All right, and again, the addition rule that we just talked about as well is the probability of A or B would be the probability of adding A and B together. All right, now let's just kind of wrap this up. Suppose you tear open the corner of a bag of M&Ms, yummy. Pour one candy in your hand and observe the color. According to Mars Incorporated, the maker of M&Ms, the probability model for a bag from its Cleveland factory, we'll show that here in just a second, and we'll explain why this probability model is valid. So they have the different probabilities. I'm not sure which one is which color. They didn't say what that was, but if you add up each of those probabilities, we know that the total number is going to be 1, so we're not leaving anything out, and that's why it's valid as we do those. So again, some reason the PowerPoint did not show which colors were which probabilities, so they're not all equally likely as you go. So So find the probability that you don't get a blue. So an easy way to do that is to say, okay, well, blue, the probability of getting a blue is about 0.207. So the probability of not getting one would be the complement, 1 minus that. And that's how you can use the complement there. What's the probability that you get an orange or a brown? So the probability of getting an orange that we have here is there. So orange is 0.205, and the probability of getting a brown is 0.124. And again, because they are mutually exclusive, I can just add those together. I can't get an orange and a brown at the same time. I got to get one or the other. So it's simply adding the probabilities would tell you the probability of getting one orange or brown, so 0.329. All right, well, that's going to take us through the first half of section 5.2. Until next time, I'm Mr. Boone.